Welcome to this lecture video. In this lecture video, we want to obtain a scatter plot in SPSS. What is the aim of this scatter plot? The aim of a scatter plot is to show the relationship existing between two or more variables. But in this case, it's two variables in particular. A simple case where we have X and Y. X are the horizontal axis and Y are the vertical axis. So does any relationship exist at all between the two variables X and Y? Then again, you could also go further to investigate the strength of the relationship. You can investigate whether it is a strong or a weak relationship. Of course, that will take us to correlation. Then again, you could also check if the relationship is a positive or a negative one. So you want to know the pattern of the relationship. Is it a negative pattern such that when one variable increases, the other variable decreases? Or is it that both variables are moving together in the same direction? That is, when X increase, Y increase. Or in other words, increase in X leads to an increase in Y, and a decrease in X leads to a decrease in Y. Then they are going together. But if an increase in X results to a decrease in Y, and vice versa, then that kind of relationship is a negative relationship. And of course, we can show this in SPSS. So I'm going to show you in this video how you can use SPSS to obtain a scatter plot, which could be useful for statistical analysis. All right, so we go to SPSS. This is my screen where I have three variables: height, weight, and then smoking status. Now, for the smoke, this smoke is categorical. It's a qualitative variable or categorical variable. The weight and height are quantitative. So, of course, we're particular about the weight and height. Then, of course, we'll come to another scatter plot where we could also involve the categorical. But you need to go to the bottom of this screen. You will see two screens: data view and variable view at the bottom. So you click on the variable view just to double check and ensure that you input the data correctly, so that SPSS will understand exactly what each of the variables represent, and of course, what you intend to do, so that SPSS could do the right thing and return the right result. So here in this case, have a look at this. You could see that for the height, it is scale. That's fine because it's quantitative. Weight is also scale. That's fine for the weight. And then the smoke, of course, this could be nominal or ordinal, depending on the way it is being used in this context. But of course, in particular, you could also check the values. 1 is not smoked. 2 is occasionally smoked, and 3 is regularly smoked. It's showing decimals, and of course, we're not happy with that decimal. If you want to see the decimal, you could go back to the data view and then go to view at the top icon, click on value. So you could see the value label. It's showing this, so we're not happy with that. So you go back again to decimal and take it off so that there will be no decimal. So if you go back again, you will see that no decimal. And if you view here, you go to value labels, and then you see, of course, it's still the same as what we've got. So now we want to obtain the scatter plot. Go to graph. From graphs, move down to legacy dialog, then proceed to scatter. So take the scatter, and then we're dealing with simple scatter. If it is for multivariate case where you have many variables, then of course you could go to matrix scatter. And then there is also an option of simple dot. If you need the simple dot, that's also fine. If you need overlay scatter, if you need 3D scatter, of course I will show us at some point this simple also. So we define, in this case, our weight goes to the y-axis, while the height goes to x-axis. So we're happy with this. Then we proceed. Okay. And then you could see the scatter plot showing the relationship between height and weight in SPSS. If you want to include the line of best fit so that you will know whether it is positive or negative relationship existing between the weight and the height, that would be great. But how do you do that? Right click and then go to edit, click on edit, and then elements. Click on that element at the top icon. Then you scroll down to fit line at total. And that will be done for us completely. So you can see that we fitted the line. This is called the line of best fit in case of linear regression model. So we have the line of best fit, and it has even estimated the relationship y equals to minus 45 rather, y equal to minus 45.41 plus 0.64x. So this is the kind of relationship that exists between x and y. But of course, in the case of I correlation, I does not imply causation, it's just the relationship. So in this case, it is a positive relationship. When you see it going in this direction, it is positive. But when you see it sloping down, if it is sloping downward, then it is a negative relationship. Or rather here, you could see it going up. So it's a positive relationship. Increase in our height result to a corresponding increase in weight. So you could see the scattered. Now you could also determine whether the relationship is strong or not. We are seeing R squared linear equal to 0.265, as you could see here. And if you want to get that, you could go further. For instance, we could go to analyze, and then you go to correlate, then bivariate. And we have the weight and then also the height. Then what do you want? You have option style, bootstrap, and so on, confidence interval, but we don't need all of that. Also, correlation coefficient, we need the Pearson. We also have the Kendall's, tau B, and also the Spearman correlation coefficient. And of course, for test of significance, it could also test two-tail or one-tail. Of course, for two-tail test, where you're saying that they are not correlated, then also maybe you're saying the correlation coefficient is equal to 0. And then the correlation coefficient is not equal to 0. So whenever you're using is not equal to, it is two-tail. So if it is not equal to, then it could be greater or less than. That's why it is two-tail, two-sided. But if it is greater or it is just less than, then it is one tail. So take note, for two tail is when we use not equal to. So in this case, the hypothesis is saying, the null hypothesis is saying that the correlation coefficient is 0, which is to say that there is no correlation between weight and height. There is no relationship. While the alternative hypothesis is saying there is a relationship between the weight and the height. So you could proceed now if you're happy with the test. If you're not happy with it, you could untick. And then now we can say, okay. So you can see now that we have our results. Correlations. Look at the Pearson correlation is 0.515. So which means there is a moderate positive correlation between the weight and the height. Of course, you could see the significant p-value is less than 0.01. So this actually proves statistically significant that there exists a correlation or a linear relationship between the weight and the height. If you proceed also, you could see Pearson correlation, same value. And then you could see that is for the height. And then for the significance, it's just exactly the same result. So for this is correlation is significant at the 0.01 level for a two-tail test. So we have statistical significance. Of course, that's just to confirm the strength of the relationship. Of course, we know that it is positive, but you want to know the numerical value, whether it is moderate. Yes, it's moderate in this case because it's about 51.5% or approximately 52%. All right, we'll take this off. Let's assume we want to include these categorical variables. So we set markers at this. So it's also possible to have a scatter plot where you can include markers, and the markers will take the categorical part. So in this case, we still go to graphs, legacy dialog, scatter, simple, define. We have everything as we have. Then the smoking will now be set markers by smoking habit. So we'll bring the smoking habit into the rectangular box for set markers by. Then now we could go ahead and see what will happen. So you can now see the color. In this case, we have the color for not smoked, the color for occasionally smoked, and the color for regularly smoked. And then you see all of this. The height in CMS and also the weight. We could also have the line of best fit with no issues. Right-click on the graph. Sorry, yes, it's a graph. So when you right-click on the graph, then you go to fit line at total. And that will get it completely done for us. So we fit line at total. And you could still see all of these shown clearly here. All right. What about the last part? We're done with it, but assuming you want to do further operation, maybe in the case of the dot, you could also apply it for other purposes. When you go here, you go to graphs, from graphs to legacy dialogs, you go to scatter, and if you're happy with simple dot, if that is the one, we also have overlay. Overlay also is an option. We have the simple dots, if you're happy with that. So if it is the overlay, is this, then you define. In this case, you have Y and X pair. So you can go to what you want to do here, Y variable, X variable. So Y variable will be the weight, and then the X variable will be the height. So you can see what we've got. Label cases by, if you want to label cases, maybe include this to label the cases, assuming you're happy with that. And then you could proceed to say, okay, and see what it will be. So you could see exactly what we have obtained now. So there are different options on what to do when it comes to analyzing quantitative data, and in particular, representing them using scatter plot in order to determine the relationship existing between the variable. Thank you so much for your attention. Thanks for watching this video. But let me add also that if you could leave a comment while you watch this video in my YouTube channel, that would be very great. You can as well like it, and of course, that would be greatly appreciated. Thank you once again for your attention, and thanks for watching this video.